Here we go. Okay. So again, I'm going to go through the solutions here. Okay, so number one, okay. Okay, so let's see. Okay, good. So here we have a team of 8 basketball players, right? And they need to choose a captain and a co-captain, okay? So we want to know, how many ways can you do this? Well, it should be clear that there's no repetition, right? You know, you can't have someone play both parts, generally, okay? So there's no repetition here. Also, order matters, right? The first person they choose, I'm guessing it's going to be the captain. The second person's not going to be captain. He's going to be something else. They're going to be something else, excuse me. So the order does matter. So as we already saw, in such a case, we have a permutation. So now the question is, how many ways can they do this? Well, in this case, we have 8 basketball players. So in this case, we would have n would be 8. I'm using like the notation from the notes and the book, I guess. Well, the notes really. R, they're choosing 2 positions, so R would be 2. So we would have P of 8, 2. Now, I did calculate this in Desmos. So what did I get? Actually, I could do it. In Desmos, you know, I'm not going to share the screen because you should know how to do it by now in Desmos. You have 8, 2, and you end up with 56. Okay. You end up with 56. Okay. Okay, so that's the first one. I hope that made sense to everyone. Okay, so here we have number 2. So in this case, we have 2 people, Rob and Mary, and they're planning trips to 9 countries this year, right? Okay, there are 13 countries they want to visit, but they're figuring out which countries they want to skip. Okay, well, notice there's 13 they would like to visit, but they're only going to see 9 countries, right? So in this case, actually, wait, no, we got to figure out if it's a permutation or not. Sorry. Okay. Well, does the order, well, first of all, repetition does not matter. Repetition is not allowed here, right? That should be kind of obvious, you know, they're not going to skip a country more than once. So no repetition. Okay. But does the order matter? Well, the order does not matter. You know, whatever countries they decide to skip, it's not going to matter which ones they choose first, right? They're skipping them all. So order does not matter. You know, they say we're going to skip country A, then we're going to skip country B, we're going to skip country C. You know, it doesn't matter which order they're saying it in. They're just deciding which countries they want to skip. Okay. So in this case, we have a combination. Okay, because again, order doesn't matter and no repetition. Now, in this case, there's 13 countries, right? So we have n is 13. They're deciding which countries to skip. Well, they're going to see 9, so they're going to skip 4, right? So we have R is 4. So in this case, we have C of 13, comma 4, right? And that turns out to be 715. Okay. I mean, again, it should be obvious there's no repetition, right? You know, they're not going to skip a country twice. That wouldn't make sense. So, and the order, again, doesn't matter. Okay, I hope that made sense for everyone. Are there any questions at all? Okay, so for number 3, well, actually, let me move it down because they probably can't see that. Here we go. So for number 3, we have the batting order, right, for 7 players on a 12-person team. Well, how many ways can that order be made? Well, it should be kind of clear that the order matters, right? I mean, hopefully that's easy to see. You know, it's the batting order, okay? You know, they have to decide who goes first, who goes second, you know, so the order does matter there. Okay, now there's no repetition either, right? And why is that? Well, because, you know, you can't have someone go more than once, right? So there's no repetition. So in this case, we have permutations. So in this case, we have how many? We have 12 people, so n is 12, and we're making a permutation with 7 of them, right? So that's R. So altogether, how many possibilities are there? Well, that would be P of 12, comma, 7. And now what is that going to be? Let's see. P of 12, 7. Calculating it in Desmos, you get 3,991,860. That's how many ways they can do it. That's what we have. Okay. Are there any questions on that one? Okay, let's do the next one then. Oh, 3. Okay, so we go this way. 4. All right. So here, there are 45 applicants here, right? 45 applicants for 3 computer programming positions. Okay? Well, how many ways can the 3 applicants be chosen? Okay. Well, here, you know what? I'm going to do a poll. Do this for fun. Have a little poll up there just to help out. Okay. Come on, other people. Okay, so 3 people have answered so far, and they all say combination. Anyone else? I did not say it was wrong or right. Okay, so it is a combination. Now, how do we know that? Well, You can't have repetition, right? That should be clear. Right? No repetition. You can't get more than one, the applicant can't get more than one position, so to say, right? But clearly the order doesn't matter because they're all applying for the same position. So order does not matter. So we have combinations. So we have a combination. So in this case, again, we have N, there's 45, right? There's 45 people, but they have to choose 3 among those for the positions. So we get C of 45, comma, 3. And that turns out to be, what does that turn out to be? Turns out to be 14,190 possible ways. Okay, that was pretty good. Okay. Okay. Any questions on that?
Wait, you multiply the 45 by the 3, right?
45. If you wanted to calculate it, I mean, I use Desmos, but if you were going to use the factorials, right?
Mm-hmm.
You would have 45. Let me see if I can, let me make room. Okay, I'm just going to move this over a bit. Okay, that should be, yeah, that's good. Okay. So we have C, oh, wrong one. C 45, 3, right? That would equal, let's see, 45 factorial divided by 45 minus 3 factorial, right? And on the bottom, you would also have 3 factorial.
Oh, okay.
Does that make sense?
Yeah, thank you.
Okay, good. Okay. I'm pretty sure the calculators have a factorial feature in it. At least I hope they do. So I'm pretty sure Desmos does if you wanted to calculate it that way. Okay, good question. Any other questions?